cái tháng 3 năm 2020 chẳng hạn, các bạn thấy nó tăng khoảng 500.000. Ở đây là khoảng tầm 500 tỷ đó. Thì tương tự như đây so với tháng trước nó cũng đâu đó tăng khoảng 500 mấy tỷ. Và đây so với tháng trước thì đâu với quý trước thì tăng đâu khoảng 300 tỷ. Đây so với quý trước cũng tăng khoảng 300 tỷ. Như vậy cái sự thay đổi này rất là chậm, rất là ít. Và mình có thể tính được cái change này nó quite stable over time. Cái change maybe sometimes it could be like linear luôn, tức là nó thay đổi một cách cố định luôn. Đó. Thì đó là những cách mà thực tế mà nói. Ví dụ như đối với lại những cái financial modeling ấy, thì họ không cần dùng gì nhiều hết trơn. Họ sẽ dùng những cái nice forecasting hoặc là drip method forecasting, sometimes là seasonal forecasting, để họ simplify cái prediction của họ. Bởi vì đối với lại ví dụ financial modeling chẳng hạn mà bình thường thầy làm ở những công ty chẳng hạn, thì thực tế là mà nói thì thầy không cần dùng model quá lớn, quá kinh khủng gì hết trơn. Cái thầy cần tính là làm sao những cái con số, những thông số này nó trúng, nó đúng. Nó chỉ cần future nó đúng xíu thôi, thì thầy sẽ predict được là cái price của chứng khoán nó trong vòng cái khoảng cái interval nào trong tương lai. Vậy thôi. Đó, that's the point. Nếu như Đạt nó hỏi là hắn có thực sự sử dụng hay không, thì thực tế đối với data science thì họ sẽ cười là kêu làm gì mà cái model chỉ mà nó dễ dữ đó, đơn giản ghê đó. Không, nhưng mà đối với lại dân finance, dân fin thì nhiều khi nó không cần khó, cái model nó chỉ cần nhiêu đó là đủ rồi. Mọi người hình dung được không? Đó, cho nên những assumption của mấy cái model đơn giản, cho đối với lại finance nó đơn giản. Nhưng mà đến khi mà chạy cái model trong cái nội dung nó như thế nào, build up nó lên thì lại phức tạp. Nên là phương pháp tính thì lại phức tạp, nhưng mà còn lại những cái assumption với forecasting thì lại đơn giản. Rồi, any question? No, right? Okay, so that's the 4 basic methods about average forecasting, NAIP math forecasting, seasonal NAIP, and the drip methods. And should be the time for us to practice a little bit to see like how they can change, right? With the forecasting and how we do it on our studio. So the thing would be like, yeah, I would create for new code. Remember about that, we all the time had to library, okay? FPP2, okay, and that should be called out for all the function that really need to do for the tutor session. And the first practice, remember about also for the library, and I want to have the what happened? Oh yeah, fine. The function, the package called tidies verse, okay, so I can use the yeah, I can use for the pipeline function, the pipeline operation. So this will be very easy. Okay, so first of all, we want to practice 3.1, okay, for the symbol forecasting method. Now, first of all, I want to go with the AUS beer. Remember about them, okay? Would be server errors. What happened? Internet interval problem. Maybe it has some kind of problem. Hi guy, you still hear me?
Dạ vâng thầy.
Không biết vì rằng cái R Studio của thầy nó bị lỗi à?
Để thầy restart session lại.
Ok, để thầy restart cái session này. Không biết đang chờ. Cái lỗi rồi. Wait a second, ok. Mấy đứa có về, mấy đứa có coi lại mấy cái phần của thầy dạy ở bên R Studio không? Coi video không? Thấy ổn không? Hay là thấy như nó thừa thãi quá? Bữa sau thầy bớt, thầy khỏi làm video.
Dạ ok thầy.
Thầy hy vọng là ok, mà để mọi người, tất cả mọi người thấy là nó vui vẻ, yeah, để hỗ trợ cho mọi người nhiều nhất có thể đối với lại video. Rồi, ok, let's check it. Đợi xíu này, R Studio thầy tính chạy hơi lâu. Lâu dữ rồi ta. Mấy thầy gần ao học RAM rồi này. Em biết vì RAM. Đứa nào có chạy thử cái thằng Rabbit Miner cho mấy đứa? Có đứa nào chạy thử Rabbit Miner không? Máy chạy nổi không?
Em mở lên nhìn rồi thầy, rồi em không biết làm gì hết nên là em tắt luôn.
Nhưng mà cái lúc đó thấy RAM có bị tràn không? Ý là chưa xài nhưng mà ý là đã thấy RAM có bị tràn không?
Dạ em bình thường thôi, mà em không tràn là chắc không phải tràn đâu thầy.
Em không tràn là máy mà RAM ít đó à?
Không, mà mấy em là cùi nhất ở đây rồi thầy.
Nó luôn về nó bay. Nhưng mấy đứa khác là mấy xịn lắm. Chết. Rồi ok, let's do it. Thầy không biết là vì sao, để let me check for the code for one more time, okay? FPP. Yep. Library. Okay. US beer. Okay, it's good now. All right, quarterly Australia beer production, okay? Yeah, the data are available. Rapid miners is a little bit kind of strong and overwhelming for some kinds of computer. So sometimes it occupies for more than like 5 gigabyte of RAM to run on it, because that's a data mining product. So you can use all the kind of even neural network. Like if I have a time, I will show you how to run it all on. So in case like you don't really want to run it on like Python or like R Studio, you can run them all on like RabbitMiner. Very easy to do it, man. Okay, so Australia beer, right? We got all the data about the Australia beer. Remember about them. You want to check it for the hash of the Australia US beer, okay? If you want to do it, you see like how they will be fluctuating, right? The data from 1956, quarter number 1 into the 2010 quarter 2, okay? And now I just want to think about like okay, a US beer, and remember about how we can generate for the outer plot, right? I want to see how they're going on. This is the data Excel look like. Normally, all the data will be quite a lot because it's the data spread from a very long horizon of the data from 1956 right into 2010. So it's having some kind of like the upward trend in the first few years, but later they fluctuate in the same kinds of like average, and that would be the reason why. So with this data actually we can use the average function to just measure for the future, something like that. So okay, now we do it for the some kinds of like function. I will use the average method, okay? So how can you for the average methods, and I want to just forecast the next maybe 12 quarter, okay? 12 quarter equal to like 3 years, okay? 3 more years. And we want to check it. So how can we do it? Remember about the mean function, okay? Mean app, that's mean forecasting, okay? And then you apply for the data itself, very easy. Mean, y would be the data, x would be equal to the time you want to do it, how long it would be. Level will be c, like equal to like 80 and 95, something like that. I will show you later. But first of all, we do it very easy, right? Australia beer, okay? And for the x equal to how many? 12 periods, okay? That will be the new forecasting. So they base on all the data from the 1956 into the quarter 2 of the 2010, and they do the forecasting from the quarter 3 of 2010 into quarter 2 of 2013, that 3 year, and they provide for the point forecasting. Remember about that, I say they will be the average of all the data of the historical data. So the average, they had the same identical result for all the next 12 periods. Got it? Got it? Okay. If you want to change and the low 80 and high 80 and low 95 and high 95, that should be the contents of the section 3.5 about the estimation interval. But you can do it like with C. Normally they will be 80 and 95 and they generate for the result like this. But if you change it, you want for the interval of the 90 and 95, they will change a little bit like this. Okay. All right. And if you really gonna to create for the model and you want to grab them and compare them into the just put them the result right into the data. So I would just generate it and I do it with the beer, the AUS beer. Okay, and then I apply for the function one more time. Okay, why I had to do it? Let's do it. Okay, that's fine. I one more time for you for the mean. Okay, with mean I want to just focus for the next 12, and then for the C that could be 90s and 95 for the prediction interval. Mấy đứa có biết prediction interval không mấy đứa? Hold on. Anyone know about prediction interval? Đứa nào biết không? Hello. Mấy đứa từng học qua prediction interval chưa?
Chưa thầy.
Wow. Man.
Chưa.
Prediction interval là ok, thế thì để thầy nói sơ qua thôi để hiểu. Thế thì mấy đứa sẽ phải coi lại phần chapter là cái phần mà 3.5 là prediction interval. Maybe like I will try to show you how to do it. But like prediction interval will be something like that. Kiểu như vậy nè. Khi mà mình predict trong tương lai, hiểu chưa? Mình predict trong tương lai á thì nó sẽ có một cái dạng như vậy. Tức là khi bạn tính tất cả các giá trị như lúc nãy thì tính average, thì đây là những giá trị gọi là the old values. This one will be the future predicted value. Okay, right? But however, the further you go for the like future periods, the further you go for that, the data is not just correct with the point estimated anymore. Nghĩa là nếu như mà bạn chỉ tính những cái giá trị ở trung tâm này nè thì nó có vẻ nó không đúng đâu. Vì trong tương lai mà mình predict mà mình làm ra mình biết chắc chắn là giá trị nó sẽ chỉ là, ví dụ mình tính là average nó phải là ví dụ 100. Nhưng mà thực tế là future đúng không? Nó có thể không phải là giá trị đúng 100 mà nó sẽ nhiều hơn 100 xíu hoặc nhỏ hơn 100 xíu. Thế thì mình mới nói rằng là thay vì mình nói nó đúng 100, mình nói rằng là nó chạy từ 99 cho tới 101. Hiểu ý không? Thì như vậy cái ví dụ đến hồi predict hỏi rằng là như vậy anh predict bao nhiêu, tôi nói là giá trị của tôi 99 tới 101, khả năng đúng rất là cao luôn á. Đi tiếp thêm một khoảng nữa, ví dụ như predict for the next two period thì mình vẫn predict là khoảng tầm 100, nhưng mà bây giờ vì trong tương lai xa hơn mình không dám chắc là nó sẽ như thế nào, cho nên mình predict là bây giờ rộng hơn này, tôi dự đoán là từ 98 cho tới 102. Vậy cái vùng predict của mình rộng hơn và nó làm cho cái giá trị mình, nếu lỡ ví dụ như giá trị thực tế nó không phải đúng 100 nhưng nó vẫn 101.5 chẳng hạn thì mình vẫn đang predict đúng. Mọi người hiểu ý của cái prediction interval nghĩa là gì chưa? Ok không? Thầy nói một cách ngắn gọn là như thế. Đáng ra cái này là kiến thức mà mấy đứa đã học ở trong phần gọi là môn probability and distribution, probability and statistics and probabilities, là đáng ra phải học cái phần này nè. Nếu như học môn FBA của thầy thì thầy sẽ nói phần này rất là rõ trong một nguyên một chương luôn. Rồi ok, thôi hiểu là như vậy ha. Alright, let's go back. Okay, prediction interval, you will see like how it will look like later, but we're fine. Remember about that will be the larger prediction interval, like 95%. That means 95% I confident that my prediction will be correct. 90% nghĩa là 90% I'm confident that my prediction will be correct. Okay. Okay, this one, and I'm going to just generate for the other kinds of function layer. So I'm going to do it for the application for the auto plot. Okay. If I just stop like this could be my data. Okay. Right. This could be the data. This could be how it looked like. This could be the mean values of all the historical data. And this, the second one, very kind of like dark second one, this could be the interval of 90% confident. If you want to say I'm 95% confident that the data in the future will be just plot between like here and here, like for example from somewhere to somewhere, okay, I say like this will be 95%. All right, this is the graph. Okay, and that should be the way for us to just generate for the same thing, right? I'm using for the AUS beer, but this one now I use for the naive method. Remember naive method, that should just generate the futures based on the very last observation. They assume that all the future value will equal to the last observation. Okay, so one more time, I will not just wait my time. I will do it like with this one. Okay. A USB file. Okay, a USB, and I want to just generate it for the name method. So you just type a name, okay, and x equal to 12. Right. This is the this will be the result. You see, this would be equal to actually if you view it like for the tails of the AUS beer. Okay, you will see that that could be exactly the last observation will be 374, and that exactly will be the data they predict for the futures of the Q3 2010 until Q2 of 2013, right? That's the point. Okay, another method could be seasonal name. Okay, the seasonal name, if I still use the AUS beer and I do it for the forecasting for the as now name, okay, and x equal to 12, they generate the same. They put all the data with the seasonal model. Okay, the last one, if you want to check it one more time, you see like, for example, the Q3 of 2010, remember, they equal to the Q3 of 2009. The Q4 of the 2010, 488, they equal to Q4 of 2009. The same thing they apply for that. Okay. All right. What else? And the last one would be that could be the drip method. Okay, the drip method. So if the drip method, we still do it the same. So we use for the AUS beer, and then you apply for that. And you put in like random what forecasting. That means this one could be mean random. This means random what? Random what? Forecasting. Okay, that's a very kind of like a basic function. Random word forecasting will be used for the drip method, and x equal to 12. But here we put in like drip equal to true. That means I want to use the drip method, and that's will be the how we're gonna do. You see, like that's will be equal to the 374. That's the last observation, but add in into some kinds of extra increase over time. All right, and that will be the four methods that basically we do it. And I going to just generate a for the data. I want to select for the data. I want to just make it easy, so we grab it. Okay, I will generate for the data from like I take the success. I use the Windows start just from the first quarter of the 1992, and the end in the Q4 of the 2007. So in this period, if you do it and you see it like for the year 2, okay, year 2, and you put it on like what the auto plot function. So this will be a short period of time, the shorter, and the shorter will be the better, because now the data will look less fluctuate compared to the previous one, right? Remember about the previous one, they fluctuate a lot in the beginning of the semester, of the period, but they stable in the last period. And that's the reason why I want to just select for this period only. That will be make all the data look a little bit better. Okay, and then I add for another layer.
Sorry, teacher.
Uh-huh.
Can you explain a bit about random walking? Random walk.
Oh, okay, random walk. Yeah, dễ lắm. Random walk actually they're the same. Okay, as random walk could be mean like the futures they could be totally random, something like that. Why the people call random walk? Random walk nghĩa là này, mấy đứa có tưởng tượng tới người bị sai không? Người bị sai á, thì hắn như thế nào? Random walk nó như thế nào?
Không đoán được.
Không đoán được. Tức là đối với người bị sai, được chưa? Hắn sẽ, cái bước chân của ông đó, ông đang đứng ở đây. 2 bước chân ông đang đứng ở đây. Thế thì bước tiếp theo của ông sẽ là gì? Có thể một bước chân ông đang đứng lên đây, đúng không? Nhưng mà cũng có khả năng lắm, rất có khả năng lắm là bước chân của ông không, thay vì ông bước lên đằng trước á, thì ông lại lùi về đằng sau. The same. So they apply for the same method with the stock market. With the stock market, you can say like, okay, in the next day it could increase, but like maybe in the next day it would be down. Maybe next day it would down furthermore. Maybe the next day it will go up. Maybe next day go down. Maybe next day go down furthermore. But maybe it's also maybe go up. Go down, go up, go down, go down, 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 up, down. Thì về ứng dụng thực tế của random đối với lại những cái này nó chính là trong stock. Stock nó không thể nào predict được cụ thể trong tương lai như thế nào. Nếu như mà nói về trong một ngắn hạn này, nhiều bạn chỉ có data trong vòng khoảng tầm 20 ngày trước, cái bạn nói bạn predict về future là chắc chắn là random walk, tức là mình không biết đó là cái gì luôn. Và nó một cái các bạn sẽ học, nếu như các bạn học sâu hơn, nó sẽ là stochastic process. Là stochastic process, nó là những cái gì liên quan tới random process. Nhưng mà chắc là mình chỉ nói tới đây thôi. Mình hình dung là random walk tức là hoàn toàn trong những cái forecasting nó dựa trên một cái random, nó random ra generate. Ok, thì if we do it, I use the random walk forecasting, okay, and I put like equal to 12. They are exactly the same with the naive method. They're exactly the same with the naive method. Okay, so when I say the random walk with the trip method, that means I clarify for the component to equal to true. Argument will be true. That means we apply for the trip too. A trip means là going up. Okay, just simple like that. Okay, is that clear that?
Yeah, yes, it's clear now.
Okay,
Thank
yeah,
you.
right, thank you. All right, now let's do it with the another function. So I want to just add in for the another layers of the performance of the different kinds of like mean, okay, mean forecasting with the x equal to like 12 or 11 month only. Okay, and I want to put the auto layer. So when I apply auto layer, so we can do it with the series equal to mean. That will be just the way for us to put it. Prediction interval equal to 4. Now let's check it. GG cannot add the 2 beer at the mean equal to what's wrong. Beer 2 beer one. Hey, what happened? Ủa thầy làm gì sai đối với cặp đó người ta? Cannot add beer to mean to the upload.
Như thầy để thêm một phần auto plot nữa, thay vì ở trên là thầy ra cc plot offset mà ở dưới là thầy dùng cái min f là nó không có return cc plot offset nên nó không cho ít đó thầy.
No, normally he will allow. Because I just add for auto layer. It's not auto plot. Let's check it one more time. Let's check this one more time, okay? I don't know why. Cannot be one more to a GG plot object. I don't know, understand the reason why. Oh. That's stupid. Yeah, that's a pipeline operator. Yeah, it's not add in, but like it will be I use the beer 2 and then I mean forecasting and I apply for the auto layer into the result of the forecasting model. Okay, so that's the reason why. So you see that could be the thing I want to add in first, right? This is the mean methods, and the auto layer actually they just generate for this graph. Auto layer can create for the graph of the beer function. This could be the forecasting method. Another thing, the series mean, that means we generate for the series or the legends of the data. All right. Now, some guy will say why I have to clarify it here true. This is the reason why. Okay. The prediction interval that's overlap on each other, and I don't want to see it. Reason? Because later I will copy this base, but I will generate it with the further function, the name. Okay, and this will be the name. I'm going to check for that. Now 2 of them have been added. I repeat this process all the time because of that fun. Seasonal name. Okay, auto layer, and this will be seasonal name. Okay, 3 layer, already got it. Which one look like better? Which one look better? Which one? Yeah. Which one better? Seasonal name, right? It look like it's go fluctuate with the up and down, up and down. But let's check it for another method. Okay. Now I change it for the random word. Forecasting is, but like trick. Well, sorry for my typing. I don't know why, but like most of the time it's wrong. Trip method. Yeah, that's all we here. Should be the time to just add in for some kinds of like decoration, GG title, and I say like casting for the quarterly beer production area. Okay, and then I add for the X level. Okay, so X level would be should not be time, but like would be year, and the Y level we should add in for the megaliter. Okay, look very good now. But the series, they look, I don't want to put them into the series. I want to change the name of the legend too. So you use the guide function on our studio and you can put in for the color. No, not color like this, equal to the guideline. Legend. I would change for the legend. I don't want them to be series. That's too tedious and boring. I want to change the title of the legend equal to maybe forecasting. See how it changed. Whoa, what happened? I make it wrong? Oh. Okay. All right. This will be what I want to do. Okay, so this could be all the historical data, the three methods, including for the average methods, the naive methods, the trip naive methods, and the seasonal naive method. Okay, this will be all the three. So according to this function, I would prefer, first of all, not the average, of course, not the naive methods, but I prefer the trip methods and also for the naive seasonal methods. That look quite good. Okay. Now, that's going to be the way for us to just generate for the graph for the first one. Okay. So later, you already learned about the 4 different kinds of methods. And in the futures, when we already have some kinds of new advanced methods, we do all the time compare with this kinds of basic method. But this is the main section of the today. And in the homework, you will go into deal with this kinds of form model only. All right, let's go with the transformation and adjustment. So with the data itself, so like sometimes they will be a little bit harder for us to see like the pattern in the historical data. That make the data very hard to forecast. And if you want to increase for the accuracy of the model outcome, we have to clarify and we have to simplify the pattern. For example, with this data, Australia electricity production, you can see it like this is the data that fluctuate, the increase in the futures, right? The increase over futures. But however, corresponding with the increase with the level of the production, the fluctuation and the seasonality, they increase too. That's not good at all. That's actually just make the data harder to understand. Okay, the same thing happened when we have the same other kinds of problem like calendar problem. If you have the data of the sales of monthly, right, and you say like the sales of like January compared to the sale of the February, I'm pretty sure I can say that the total sale of January will be much larger than the total sale of February. You know why? Anyone?
In Vietnam.
What happened?
Tết season, Tết holiday.
The test holiday, yeah. Maybe.
Like they buying it's like on when they approach the Tết holiday on the shop mostly like selling a lot on the shop.
Okay, that's maybe the seasonal, but that could be what people call say the seasonalities, but it's not the problem of the calendar. Think about how many days are there in each month. January, how many days? January.
21. February less.
30.
31.
31 days. Okay. How about on February? How many days? February, how many days?
28.
28 sometime in the leap year. Năm chẵn ha. Năm nhật ha. 29 days. So think about, what do you think about that, Bro Long? Maybe you can answer this question. If I just add in all the data, like monthly sales of all the days in a month, is that fair? Is that good?
It can missing the day.
What do you mean about missing the day? Just detailedly explain about
It's maybe after fewer.
Yeah, something. Continue, man. Không nói được thì nói tiếng Việt. Whatever.
I think
A little bit.
add more to.
Okay, anyone else? Okay, thank you, Long. Very good. But anyone else? Okay, so think about this way. If I add up all the day on January's, right, I have up to 31 days of sale. And if I add up all the day in the February for the monthly sales, I just add up like 28 days only. So I'm pretty sure that, I'm not 100% sure, but like 95% I'm sure that the sales of January, they will be much larger than the sales of 28-day sales in February, right? That's the reason why. Kiểu như vậy, mọi người thấy hình dung nếu mà sale mà thì mình tính theo kiểu là cả tháng ấy, thì mình kêu là monthly sale của tháng 1 thì do nó có 31 ngày lận, cho nên add up vô toàn bộ 31 ngày nó mỗi ngày sale xíu add up vô là mình thấy nhiều. Ngược lại với mà monthly sale của February nó chỉ có 28 ngày thôi, thì add up lại nó rất là ít, nó không đủ. You got it? Đó thì làm như vậy.
Mình assume là tháng 7, tháng 8 có thể bằng nhau đúng không thầy?
Thì mình cứ assume là như vậy, nhưng mà ý bạn thấy là vì trong một năm có những tháng có 30 ngày, có những tháng 31 ngày và có những tháng có 28 ngày không? Thì nếu như mình dùng theo kiểu mà add up ấy, là nó không có fair để mình consume, để là mình kiểu như assume for all the things. Right? So that's the reason why we have the calendar adjustment. We remove the variation in the calendar average by divide the number of the month for the number of the day in the period. Okay, so if we have the monthly data, we divide maybe all like on February we divide for 31 days. On February we divide for like 28 days. If that's be quarter data, like for example, we divide for like about 90 days. Okay, so we got the daily data. That's really better. The same thing for population adjustment, right? The population of the each country will be different. When we talk about the GDP, okay, nobody talk about like we compare about the GDP of country. Oh, when I say like that, because the GDP of the United States, actually they're about 22. Yeah, here, $22,000 million, and China that will be $16 million. And Japan, this would be like $5 million. Sorry, $5,000 billion. Okay, $5 trillion, something like that. But you cannot say like China, they are richer than Japan, right? Even when you see like the total GDP of them will be larger. But if you want to do it, you have to deal with the GDP per capita. You see, like for example, now you see like per capita of China. All right, that should be $10,000. Okay, however, even when they make it a lot in the total GDP, that's up to like 15,000. But for each person, they just make like 10,000. But like now we play with Japan. That's 40,000, 4 times larger than what they do for China. Even one for the gross domestic, they're just $5,000 billion. That's the reason why. Okay, so that's why the people recommend about population adjustment. They have to adjust the total value for per capita data. Per capita tức là từng người. Nếu mình dùng những cái dữ liệu nào liên quan tới cả một quốc gia thì mình tính từng người. Inflation adjustment the same, so the price get down over time. That's the reason why if you really have the data from like what I already downloaded, IBM. The data of IBM, if you, nếu như mấy đứa làm phân tích dữ liệu thật nghe, đối với lại về data của những thằng công ty á, thì họ không bao giờ họ dùng cái cục close này hết. Giá close 7.62 đô năm ngày 1 tháng 2 ngày 2 tháng 1 năm 1962 là 7.62 đô. Mình không thể so sánh cái con số này với lại cái con số của ngày mùng 27 tháng 10 năm 2021. Lý do gì? Inflation. The money lost the value over time, right? That's the reason why they generate for this one. Adjusted close. Adjusted close là cái giá gọi là giá điều chỉnh. Nó sẽ tính cả lạm phát và tất cả những cái giá trị khác vào đây. Nghĩa là nói, thực tế là mà nói, nếu quy đổi theo giá trị của năm 2000 tới recently này, thì giá IBM là khoảng đây, 125. Nhưng mà nếu như mà đúng ra thì năm tháng 2 ngày 1 tháng 2 năm 2020 năm 1961 ấy, thì giá của một thằng cổ phiếu IBM nó chỉ khoảng tầm 1.8 đô. Như vậy over like about 60 years they increase almost about 80 times something. That's a lot. Hiểu được không? Okay. And the same thing like inflation. And another way could be mathematical transformation, and I just most of the time talk about the reduce for the variation by the change it by the kind of like mathematical transformation, mathematical function. And we most of the time we use just the kind of like algorithm and power transformation and boxcar transformation, especially for boxcar transformation. That should be the both the kind of like the interaction and integration of the algorithm, for logarithm, and also the power transformation. For example, you can see like this. This is the boxcar transformation, and this should be all the function they're gonna do with that. So with the original data, they change it. If you use it for the box plot transformation, and the thing could be like you don't have to do it manually. This would be the function and you have to understand itself. But however, if you do it by the computer, they will just automatically generate for you. Okay, and this would be how the people do it. So this the box plot transformation. I recommend you guys just go and practice with the box plot transformation by yourself. So for the practice 3x2, I will not spend the time for you. Okay, you have the function, and you also have all the data available on the book, and also for my video, you have to take a look onto that. The thing will be like I want to say, if the data let's keep the same with the original data, this will be the electricity production of the Australia, the original data plan, right? But however, if you change for the lambda, that will be the function over here. Okay, the function over here, they change it by, they take the original data, they power it on minus for 1 and then divide for the lambda. That's kept to transform the data. Okay, so let's come back with the cost plot, and they change the lambda. Like if they equal to 1, that means we don't transfer the data. If we increase one the data up lambda, what gonna happen? You see, it's strengthened and make it more serious about the variation. Beginning of the period, the variation it was very small, but however, in the end of the period, the variation go up and up and up and up, and it become larger over the time. If I do it with another one, maybe in the opposite side, can I do it? The lambda will be a kind of like a negative values like minus 0.8. Yeah, but now it look very weird, right? You cannot see it like with the totally different to our previous data, right? So now the fluctuation, the variation is very strong in the beginning of the period, but at the end of the period, That's very small. So the thing would be like, I would try to make it like how it could be look like. The variation is the same over time. It should be, if it lasts, it should be last in the even the beginning, even in the middle, and even in the end of the period. So I'm going to change it until when I see it like, yeah, it look a little bit better now. Continue. Look good. 1.1. Yeah, much better. 2. Yeah, fluctuation. Beginning, middle, and look close enough. And when I say it like 0.3, very good. 0.4, very good. 0.5, no longer very good because it look like this small, but this one big. So I will think like 0.4 would be good, 0.3 would be good, or maybe something exactly in the middle of 0.3 and 0.4. But the limitation of this transformation would be like just like this one, and that's the reason why it's not so good. But yeah, we can do it. We can find the optimal transformation data. Okay. So for example, like I would just do it very quick. Okay. I use it very quick for the data, and I'm going to just demonstrate for you in the section number 2.3. So practice 3.2. Okay, transformation. Okay, so if I check for the data of the electricities in the Australia, right? That should be the original data, right? And the box cost lambda, remember the box cost lambda, that should be the method for us to transform the data about this way of methods. We would try to form the original data. We make it become the better data. Okay, the better data. So we will try to generate something like this. Okay, so how we gonna do it? We can just use for the box cost lambda and elect. So they return for values if you do it like this one. If you do it like this one, they will just assume the value should be like 0.265. All right, that makes sense, right? I make it round a little bit, but it should be somewhere between 0.2 and 0.3. Okay, so that's in the middle. 0.25. 0.2265. Sorry, that's the best lambda that you say. So I say this will be okay. That will be the lambda. So that should be the lambda. Okay, the lambda. So that will be the data. I call it the lambda. And now I do it with the elect data originally, but I change it for the box cost. Okay, with the data here, with the lambda that I already put in. Okay, lambda, the 2.65. This is the lambda object now. Okay, and then I'm going to just generate it for the auto plot. That's it, how it looks like now. Compared to the original data, elect, but I put in like auto plot function. This is the original data. This is the new data transformed already. Look better. Okay, that's the point of this section. Okay, and this will be the 3.2. We'll take a break about like 5 minutes. That's okay. Okay. About 5 minutes break.
Yes.
Yeah. Any question about this section? Có câu hỏi gì về đoạn lambda này không? Cái phần này là phần toán, cho nên thầy không muốn dùng thời gian nhiều lắm để nói về nó. Nhưng cơ bản có nghĩa là cái data này nó dựa trên một cái gọi là cost block transformation, nó sẽ làm data của mình smooth hơn. Nó làm thành một cái data, nó loại bỏ đi cái tính chất thay đổi về variation của cái bit variation of the data over time. Và nếu như mà cái data nó stable như vậy này thì khi mình bỏ vào model, accuracy của nó sẽ cao hơn. Thì đến cuối cùng quan trọng nhất là accuracy mà thôi, không có gì. This section you will have to read a little bit more in the book. They will be in more detail, okay? Just tell you kind of a short part about that one. Box cost blast and the bias adjustment. This is kind of totally all the mathematics. You will have to learn how to just back transfer. Back transform nghĩa là lỡ như hồi nãy chúng ta dùng cái function này để chúng ta tính ra được cái giá trị, biến thành một cái đồ thị đẹp hơn như thế này, biến thành một cái data đẹp như thế này. Thì ngược lại, đến khi mà chúng ta chúng ta phải batch transform nó lại thành cái original data sau khi mình đã dùng model rồi để mình tính. Hiểu là như vậy thôi. Thì toàn bộ trên cái video của thầy á, thầy đã có hướng dẫn là trong phần này làm như thế nào để batch transform được luôn rồi, nên mọi người không có gì lo hết. Ok chưa? Right. Later we will talk about residual diagnosis. That's more important, and also for the evaluating the forecasting accuracy. Okay, let's take a break. Okay, let's continue. Bart, go. Right. Now the time for us to plot this in the chapters like 3.3 is a residual diagnosis. What exactly does mean residual? Remember about all the things we talk about the model, right? The model can generate for the kind of estimation, the estimation between the real data and the difference in there. And the real data and the fitness values. So what the people call, they could be the forecast based on the this would be all the forecasting, and we call that could be fitness values. Sometimes we hope that the values generated by the model is very good. That's good enough to be very close to the model itself, to be very close to the result itself. But however, sometimes it does not work like that. Why? For example, I come back with this one, okay? And this is the fitness values. I'm generated. Mấy đứa có hình dung, mấy đứa có hiểu cái residual, mấy đứa nếu mà hiểu residual thì thầy không cần dạy. Còn nếu không thì phải nói sơ sơ. Anyone know about what is residual mean? Anyone? Or I have to explain this. Học đến cái học probability rồi là phải biết cái này, phần statistics là sẽ biết cái này. Anyone? Mấy đứa học chưa? Chưa à?
Em cái đó có phải là cái phần kiểu phần dư ra khi mà so sánh cái giá trị thực với giá trị của mình predict không?
Rồi, cái vấn đề khoan đã. Thế thì nó ở trên, thầy hỏi này, residual nó xuất hiện thế nào? Nó xuất hiện giữa, nếu thầy có giá trị tương lai đợi đến mấy ngày nữa được chưa? Thầy xuất hiện ví dụ giá trị này là 100, giá trị này 101, giá trị 102, giá trị này 103, thấy chưa? 104 và 105, giả sử như thế. Đây là giá trị thật nha. Còn đây là giá trị thì estimated. Thầy muốn hỏi là theo ý bạn Đạt như vậy thì residual đó là cái gì? Theo ý Đạt như vậy residual là gì? Biết không? Nếu mà mình nói là giả sử như thầy so sánh nha, giữa cái native forecasting này này với lại cái giá trị thật này, cái gọi là real observed values này, và cái này gọi là fitness value for the future forecasting á, được chưa? Được chưa? Thì cái này được chưa? Nó sự chênh lệch này cái 2.52 này nó được gọi là không phải residual, nó được gọi là để thầy demonstrate
Error rồi.
errors, nó gọi là sai số. Trong tiếng Việt gọi là sai số, nó gọi là errors. Yeah. Cái này gọi là forecasting errors. The difference between real future values and forecasted value. Yeah, đó, được gọi là forecasted errors. Một kiểu forecasted errors. Có nhiều cách tính error khác, nhưng đây là một kiểu một. Còn nếu thầy apply for cái result này, cái forecasting này lại về ngược lại cho cái data cũ. Yeah. Và cái difference này đây giữa cái data cũ và cái fitted value này. Yeah. Những cái này, sự khác biệt này, một dạng như thế, thì cái phần này, toàn bộ cái phần này all the data like this, all the data like this, all the data like this. Okay, this is what we call the residual. Okay, right. Okay, residual nghĩa là cái sự khác biệt giữa nếu mình dùng cái model này, mình apply nó cho cái data cũ và mình tính nó ra được là cái difference giữa cái giá trị thật của data cũ với lại cái fitted value của data cũ, cái mà tính theo cái model đó thì nó gọi là cái residual. Còn cái phần mà trong tương lai mình chưa biết được, được chưa? Đợi đến khi nào mà có available data rồi mình so sánh với lại cái forecasted value của mình á, thì mình gọi là forecasting errors, tức là sự sai khác giữa giá trị mình dự đoán so với lại giá trị thực tế. Đó. Thì hai cái này khác nhau nha. Residual là dành cho gọi là testing success đó, cái mà cái data testing data nó apply on the training data. Yeah. Apply trên cái training data của mình có chừng này mình xài nó để làm train toàn bộ cái data này thì nó sẽ là residual. Còn cái phần mà forecasting error là nó sẽ apply on the testing data. Mấy đứa biết rồi đúng không? Training data với testing data thì mình chia data ra thành hai phần, như một phần 3%, một phần 7% để mình test. Đó là cái chuyện này. Thì residual hiểu là đơn giản là nó sẽ apply lên training data, trong khi đó là testing forecasting error nó sẽ apply lên testing data. Okay, that's the point. Okay, so that's why I say the residual, the difference between the observed value and its fitted value. Fitted value, that's the value based on the forecasting. Okay, right. And now, so when we talk about the residual like that, the larger, the more the residual it is, that means the more inaccurate the data ourselves we are doing, right? Right? If we make it the residual too big, that means, oh, your forecasting is so bad. Because you cannot just explain all 100% of the data. You just make it like about 70% of accuracies and about 30% had not been explained already. So that means the residual, the larger the residual, the less accurate your model is. And that's the reason why we have to make sure that the residual has some characteristic. That means the residual itself is now minimal. Now that means we already try to make it small as much as possible, and it don't have any kind of problem in that. Some assumption about the residual including uncorrelated. That means, remember about the last chapter about the autocorrelation, remember? Autocorrelations tell us that we have the relationship between the current values and the previous values. Now, they should be uncorrelated. That means they don't have any kind of correlated between itself and the previous data. Okay, and it had the mean zero. That means all the residual, some of the residual, they should be like minus, like negative. Some of them could be like positive. Some of them is small. Some of them is big. But however, the average of them should be zero. Okay, if not, the forecasting will be bad. And the two other, but not like must have but should have useful property that's including like well, they have the contrast variant and they also have the normal distribution. Contrast variant will have us to save it from the historicity of the model. Normal distributors could have made sure that all the data is normally distributed. Okay, that would be the point. So because that we go and just generate for the prediction forecasting like prediction interval, so they had to have the constant variant and they should have the normal distribution to make sure that we can easily do it for the prediction of the interval. Thì cái interval nó nghĩa là như thế này. Hồi nãy có một lần thầy vẽ cái model đúng không? Cái pen. Vì sao phải có những cái tính chất này? Đây là cái data đúng không? Cái data Excel này. Giả sử đây là cái data Excel. Rồi. Sau đó thầy vẽ được một cái data nhưng mà là dạng prediction. Được chưa? Prediction của thầy thì đôi khi nó cao hơn cái data nó thực tế, đôi khi thấp hơn data thực tế, đôi khi nó thấp hơn data thực tế này xíu, cái đây đôi khi nó cao một xíu, cái đôi khi nó thấp hơn xíu, đôi khi nó cao một xíu, đôi khi thấp hơn xíu, đôi khi cao hơn xíu, đôi khi thấp hơn xíu, đôi khi nó cứ như vậy hoài đến đó. Đôi khi nó get along with, đôi khi they're exactly the same. Sometimes that should be a little bit different. Okay. Vậy cái màu đen là cái predicted data, cái real value data và cái màu đỏ là predicted values. Ok, thì cái difference, right? The difference between the two. Mỗi lần như vậy có sự khác biệt giữa real data với lại cái predicted cái predicted value, những cái giá trị như vậy. Đôi khi nó không có gì hết, không có khác biệt. Đôi khi khoảng khác biệt khá nhỏ, đôi khi khoảng khác biệt khá nhỏ, nhưng mà đôi khi khoảng khác biệt lại rất là lớn, đôi khi khoảng khác biệt rất lớn. Đó, kiểu như vậy. Thì mình nhìn thấy có những cái phần này là sự residual. Thì mình hy vọng là cái residual, nếu mà mình tính ra được á, cái residual này nếu như lần đầu tiên mình vẽ ra trên một cái đồ thị, cái residual thứ nhất, dụ giả sử sự khoảng cách ở đây giữa hai giá trị này là 5, thì nó nằm ở đây. Sorry. Ok. Giả sử lúc đó khi mình vẽ residual của mình này nha, thì giá trị của nó, cái đầu tiên là 5 vị trí ở ngay đây. Sau đó cái residual của mình nó hắn nhỏ hơn xíu, hắn giảm xuống một xíu thì còn đây. Rồi còn lại tầm ví dụ giá trị đây là 5 chẳng hạn. Thì đây còn giá trị là 4 chẳng hạn. Đó. Giả sử mình mong là hắn đi xuống như đây, hoặc là đi lên đây, hoặc là xuống như đây. Nhưng mà mình mong là sao hắn stable, cái variate, những cái đặc tính này. Mình có mong là variation của hắn có thay đổi nhiều không? Tất nhiên là không, đúng không? Mình không mong muốn là những cái đặc tính như là thứ nhất, they should have the mean. Mean là tức là tốt nhất là cái residual này có những giá trị, đôi khi nó những giá trị là 5 như thế, hoặc là đôi khi nó 5 thì to quá, giá trị ví dụ như là 1 là 1. Okay, let's go back into the brush like 1. Okay, so we hope that it's sometimes like this, but sometimes it should be smaller. This should be 0. Okay, so it should be like -1 something. Okay, but sometimes it fluctuate up, fluctuate down, fluctuate up, fluctuate down, fluctuate up, fluctuate down, fluctuate up and down, up and down, up and down. Okay, because this should be the time. Okay, time of the data. Okay, so we hope that they had the mean, 0 mean. That should be they all fluctuate between 0. Second of all, they should be uncorrelated. That means this one, the residual in this period is not correlated with the residual in the previous. Okay, they should not look like this. They should not like going up. No, I don't want to see this one. They should not going down. No, too. Okay, they should fluctuate between 0 like this. They should not have any kind of trending or something. They should have the constant variant. Constant variant là như vậy này. Thầy không mong là nó có constant, không constant variant là như đây. Cái sóng lại nhỏ xíu này. Đây, cái lại nhỏ xíu này. Cái lại có những cái đoạn rất là to vậy. Thì nó không phải là constant variant. Và normal distribution, tức là đến khi mà thầy vẽ tất cả các residual này thì sẽ có những residual rất là to. có những residual rất là nhỏ, nhưng mà phần lớn là những residual mức độ trung bình, ví dụ như là đâu đó nó khoảng từ -1 cho tới 1 thôi. Vậy ra. Còn lại có những residual rất là to, rất là nhỏ, ví dụ như -10, những residual rất là nhỏ, lớn như là 10 chẳng hạn. Đó. Thì những cái này có dữ liệu rất là ít. Còn lại phần lớn các residual nó sẽ là nằm trong vùng từ 1 tới -1 chẳng hạn. Bây giờ hiểu ý của 4 cái chữ này là sao chưa? Mọi người hiểu ý của 4 cái hình vẽ này là sao chưa? 4 cái đặc tính này là của residual là như thế nào chưa? Got it? Guys, khó không? Khó không? Thầy giải thích cái này so với các thầy cô khác có khó hiểu không? Hay dễ hiểu hơn? Guys? Hey?
Dạ, hiểu rồi thầy.
Dễ hiểu không? Hồi trước này mấy đứa có học phần residual này ai dạy bao giờ chưa?
Không nhớ rồi.
Chưa nhớ luôn, nhưng mà không biết là những đặc tính này của các đặc tính của residual.
Dạ.
Mấy đứa run regression model này, ví dụ multi regression model này, các mấy đứa run những cái như là phần mà econometric model này đều phải dựa trên cái residual này hết. Kể cả run ví dụ random forex cũng phải là dựa trên residual hết. Được chưa? K-mean cluster đúng không? K-mean cluster là hoàn toàn dựa trên cái residual để nó fit lại cái K value mà. Đó, thì toàn bộ tất cả những cái này nó đều là residual, nó dựa trên những cái này. Thì residual nó phải có những tính chất. Thứ nhất, uncorrelated, tức là nếu như tính nó được residual, nó không được tăng dần, không giảm dần theo thời gian. Thứ hai, zero mean, nó có fluctuate between zero thôi. Thứ ba, constant variance, nhớ variance của nó, cái residual này nó chỉ là những cái variance của nó, tức là có những giá trị to, giá trị nhỏ, nhưng nó vừa vừa thôi, đừng có quá đá. Và nếu như mà đã constant variance rồi thường nó cũng sẽ normal distributed, tức là nếu như tính các giá trị mình vẽ nó histogram của nó ra thì mình sẽ thấy rằng là residual của nó phần lớn là nó tập trung vào trong những giá trị vừa vừa đúng không? Và nó không ít khi nó gặp những giá trị residual rất lớn và ít khi có những giá trị residual rất nhỏ, kiểu như vậy. Đó là 4 đặc tính quan trọng của residual. Và sau này cũng tương tự như vậy đối với lại là standard giống như là standard errors hay là forecasting error, nó cũng ý gì vậy, nó không phải có những đặc tính gì đâu thì nó mới đảm bảo một cái model tốt. Nếu không model mình bỏ, mình có chạy cái model chi mình run rồi mình nói rằng là model của tao xịn lắm, model của tao là dùng neural network rồi đủ thứ hết, nhưng mà đến cuối cùng residual to tướng, rồi residual gọi là violates all the assumptions like this. They correlated with each other. They don't have the mean zero. They have the constant variance. Đó, chắc chắn nếu như mà thầy dùng cái model này đúng không? Cái model này mà dành cho cái data mà cỡ như đây, thầy chưa transform, chắc chắn residual của nó sẽ variant over time. Và đó là lý do vì sao thầy cần phải dùng box cut plot để mà transform cái data lại cho nó đẹp như thế. Và thầy sẽ làm cho data của nó ít bị variant. Nó sẽ tránh được những cái ví dụ uncorrelated này, nó tránh được những cái là constant, non-constant variant và đảm bảo cho cái residual của thầy tốt, đảm bảo cho model của thầy tốt, vậy không? Okay, and with residual we have to check it all like this one, 3, like all the 4 function, right? But we can see like if they correlated or zero, you take a look into the graph of the residual, the time plot of residual. You see over here they fluctuate between 0. You see over here most of the time you see they quite stable, the variance stable. They have the difference in like in the day like about 170 something, but it's not necessary. They just like in one case only. They are uncorrelated. That means they don't have the correlation between the historical data of the residual and the current residual. You see like this, and they should have the histogram. This will be the how we see they are normal distributed or not. You see most the data they just allocated in the central, while there are very small number of them in the kind of the two tail, the kind of the lower tails and the upper tail. So that's the reason why I say you have to make sure that there will be not white noise. Actually, white noise, remember, but last time I say they are uncorrelated. They had the mean zero and they are constant variant. That's it. Okay. But don't worry, because we have the ACF chart and we have the kind of like residual check function right in the data to see how it look like. So you don't really have to worry about how you can generate, and it look very hard for us to compare. Just do it, and just do it. Okay, so for example, I'm going just brought this for the 3.3. Mấy đứa tới giờ trời có hiểu không? Hay là nghe khó khăn quá? Cái phần residual này có khó khăn gì không? Mấy đứa có gì không hiểu không? Guys?
Đến giờ bằng ổn thầy. So far so good.
So far so good. Okay. I hope that I can convey the information clearly for you. Just don't make it really hard for you so you feel like it's confusing. Okay. Now let's do it. Practice with the 3.3 about residual checking. Okay. Residual. Oh man, this is Vietnamese. Residual check-in. Okay, so I wanted you with normally when the people want to talk about that, I would just use for the Google 200. Google 200 will be the data of Google in the 200 day. Okay, so if you just use the Google, that's 1,000 consecutive trading day from 2013 into 17. Why the Google 200 just contain the first 200 observation of the data? Okay, so they just have the 200 observation. That's the daily data, and the same with the IBM data. I already put in for you to see, right? That's okay. They're the same. They're totally the same. All right, now let's do it and check it like for the structures of the 200. No, sorry, Google 200. Okay, this is the time series 200 observation. If you take a look, this is the 200 because it's the kind of data like this, all the data and daily data, so they don't have to really clarify about what quarters or month, right? It's just totally daily data. Okay. All right, now let's first of all plot the series. Okay, so I use the Google 200 and then I use for the highlight function auto plot. That's very familiar, right? Okay, this is the function. If you want to add in one more time, CG title. Okay, you want to have the chart title, so I say Google stock price something.
Technologies is trading at $155.26 a share.
You hear something? I say Google, and then they just search for the Google's price right on my phone. It's okay. It's just fun. Okay, Google stock price. Okay, something like that. Okay, and then I want to ask for the X level. The X level will be day. The Y level, that should be like closing price in USD. Okay, in dollar. Okay, I guess that should be good, right? That should be the point. Okay, now that's I have to go and check it. Like this is the original data, right? And I'm now going to check it for the data that I check the fit between the fittest result generated by the naive method and the real data. Okay. Okay, so I'm gonna just apply for the real method. No, sorry, the Google, and then I apply for the naive method. Okay, no, not this one, but naive method, and then this will be the all the kind of like calculation and the forecasting. Okay, and then I'm going to check it for the data for the fitted values. Okay. So if I generated this one, this will be all the data of the 200 day before, but they will generate all the data for the next 200, for the previous 200 day, right? The historical 200 day, all the data the same with the previous one. If you see it, right? That would be the from the day 1 into the day 200, and this is the fitted data based on the naive methods. Okay, so they just use the data from the first day, the same with the other day. So for example, the first day that's going to be 392.830. They will use it to be the day, the forecast for the day 2. The second day in the series 392.51. They use it for the Thursday forecasting. You got it? And that will be how they fit the data. So that's why I say the ratio data, they will be the data applied in the kind of like the training data, not the testing data. Remember? Okay. And if that could be it, I would just call it like fit. Okay, the fit data. Now, let's go and check it. Let's plot it at the same time. Okay, let's plot it 2 of the layer at the same time. But now I'm just generate it like with the another like plot with the outer layer. Okay, and I want to put the fitted data, and I say the series. Okay, equal to the this value. Okay, that should be it, and plus. And this one, the other thing is good. The only thing I want to do would be like, I say the series equal to the what observed or real data. Okay, real value. Okay. All right, this is the point. Okay, so you see like that should be like of course 1 day last, and that's the difference between the real data on those days and the forecasted data. Okay, so that's the way that people can just generate for that one, and we have the fitted value already. But even for this kind of graph, we're not sure is there any kind of problem about the residual. Let's have to check it. Check the residual. Okay, by the function residual check. Okay, by the function we will say the check residue. Okay, but we'll use it later. First of all, we can easily just generate for the graph. What happened? Okay, so first of all, I want to just generate it for the graph. I create the residue already. So Google 200 one more time. I generate it and name. Okay, one more time, and I just use the residue. Okay. The residual function. The fitted data will be the data of fitted values. But the residual function, this will be the difference between the fitted data and the original data. Okay, so if you do like this, this is the difference between the fitted value and the original values. Okay, if you want to see. All right, and I assume they will be I call it the residual. Okay, this is the function. You can assume you can assign them like this way, or you can assign them like residual this way. They're the same. Okay. You do it whatever you want. Okay, and I have the data. Now I want to check it for the graph. Check the graph of the residual first. Okay. So what I'm gonna do? Of course, auto plot. Okay. With the residual. Okay. This is the graph of the residual itself. Okay, you see like what they really fluctuate and how they look like really like this one. Okay, of course I can add for the layer of the plot. Like I want to just add in like X level, right? For the day, not X level. Y level, and we just add in like nothing because the residual they don't have the kind of value. Right, Okay, and then I plus for the GG title, of course. Residual of the name method to real data. Okay. That could be the point. So you see over here, they fluctuate between 0. Look like they will have the mean by equal to 0. They don't have the correlation. They have quite a stable variant. Okay, so it looked like they meet some kinds of requirement about constant variant, about the mean 0, and we're gonna check if they had a correlated between the autocorrelation between the residual. Okay, so check the autocorrelation of the residue. Okay, and remember about what I got to do with that? Residual and what?
Autopilot ACF.
ACF. Yeah. This is what they're going to do if you really want to add in. Okay. Residual. Oh, the series, it looks not good. I changed it. GG title. Okay. The ACF of the residue. Okay. So this case, you see, like they don't have the autocorrelation of the residual. Residual, they don't have the relationship between the current variable, current residual, and the like last 1, last 2, last 3, last 4, last 5, last something like that. They all beside, not get beyond the dashed line, right? Get beyond the limitation of the critical values. So they are good. Okay. So we can say like they don't have the autocorrelation in this one. Okay, and check the distribution of the residue. Okay, how can we do it? One more time. We check it by the function residual, and we say GG histogram. Okay, GG that means graphic. Histogram that means the name of the data. The name of the kinds of graph you want to do. GG title. Okay, and do it with the histogram of the residue. See it right here. Okay, and it looked like even not perfect, and there's some kind of very last values up here, like up to 60. That can make sense, right? That makes sense, right? Because this residue when it's up to 60. But however, they will be still better than we have a lot up here. We don't have a long right tail, okay? We don't have very long left tail. All the data, it fluctuates between like 0 and most of the data, they will be just not so different. They concentrate in the center. Very few are very small and very few are very big. That would be the point. So that's the reason why, okay? But however, even when I have a check, it's all the thing like that, I can sum all the check on one function, okay? That means what I say, the check residual. So rest, and I'm going to just do it, okay? For the, oh no, oh, if I do it like this one, I cannot do it. I would just generate for the from the Google, okay, 200, and even I don't really have to create the residual data. I just have to apply for the naive method, okay. All right, with this one, and then I check it by the check residual function, and they automatically generate everything. Good. So in the first homework, I show you a lot of the thing, but the thing will be like you just have to generate it by the check residual function, and that should be all. Okay, very convenient. Got it, right? Okay, the last thing I want to share today will be the evaluating forecasting accuracy. For the other thing like prediction interval, you study it at home. It's easy. Forecasting packet on R, you learn it at home too. So basically, forecasting packet they will include for different kind of function. You already learned about mean forecasting, the naive forecasting, seasonal forecasting, random walk forecasting. Okay, but however about the later for the STL, for the say seasonals, the horn or the horn winters, the advanced forecasting method they will be generated by the forecast packet that has been already loaded automatically by the FBB packet. But however, you can use all this is all the function you can do it on this. Okay, so now let's just talk very quick about the evaluating forecasting accuracy. The last thing I already showed you what exactly is residual, right? And this is the forecasting errors. So the same thing. Now the people want to make sure about if we sure that our forecasting is really very accurate. And remember, even sometimes you do it very well with the residual, even sometimes like with the kind of like training model, you generate a very good model and you see very kind of high accuracy between the fictive values and the forecasted values and the real values, sorry, fictive value and the real values. But however, that's all the historical data. We don't know about the futures. And when you really apply the model for the futures values, for the future data, you generate for the future forecasting. And maybe the forecasting error is still very big, even when the residual is small. Okay? So there's nothing that can make sure that you can do it for the forecasting. And of course, according to what I already say, I cannot wait until when I have the new data coming out, right? For example, I want to generate and I want to test my model right away. I cannot wait until when I already have the new data. Fine. You are good, man. How we gotta do it? Just do it smart. Okay, so maybe I would just use all the data. Excuse me, sorry. You all the data like this. The data from the first 36 observation, right? The first 36 observation that I will call them will be the training data. Okay, so I use the data to generate the model. Okay, I use generate. Okay, but for the rest of them, okay, now I'm going to use for the rest of the data for like the last 12 observation. Okay, that should be what I say the testing data. Okay. Okay, so I will after when I generate for the historical for the forecasting model based on all the data like this. Okay, all this data. Okay, I will later use this one for forecasting, and I will check it. What could be the difference between the forecasted values and the real values? Okay, so that's what the basic idea about the testing in the training data sets and the forecasting error. When you generate for the forecasting already and you check it compared to the real data itself, so you can call it like the forecasting errors. Okay, so this is what the people they talk about, the main idea about behind the training data sets and the testing data sets. Sometimes you saw they call the in sample data and the out sample data. Okay, cái này chắc thầy nghĩ là chắc mọi người đều biết rồi đúng không? Mấy đứa đã học qua mấy môn mà data challenge 2 rồi, mấy môn mà về data mining là chắc chắn là đã từng làm mấy cái đoạn mà test data rồi đúng không? Đúng không? Right. Đúng không thì nói.
Đúng rồi thầy ơi, cái này học rồi thầy ơi.
Ok, học rồi là tốt. Nếu vậy đỡ phải nói giải thích mất công gì cho thầy hết trơn á. Ok, but remember that the model that fit very well with the training data doesn't mean that they will fit with the forecasting data. Okay, so we have to check it. We have to go and check it, and we use it for this is the function for subsetting. I already tell you already. Don't worry. This is the how the people really use it, and carefully learn about this part. Forecasting accuracy measurement. All right, that should be the difference. Forecasting error, the difference between observed data and forecast data. This is not a mistake, but it's just the unpredictable part of the observation. Even when we make a very good model for the forecasting, but no, I'm pretty sure that you cannot 100% accurate about the data forecasting. Okay, so the difference. So remember about the difference between residual and the forecast error. Okay, all right, and there are kind of like some kinds of function about how to do it. You have the mean absolute errors, the difference between the forecast values and the real value, and then you just take the mini kind of like average of them. You have the rooted mean squared errors. You have the mean absolute percentage error, symmetric mean average percentage errors, and the mean absolute scale errors. 5 of them will be 5 most popular data you normally use. But however, most of the time you use the MAEs, we use the RMSEs, and we use the MAPs. This will be mains of the first 3 mean. Okay, or sometimes like this one. This 4 will be the most popular. Okay, you can read a book about the other thing like cross validation and also the pi operation, but I would just basically talk about this 4 function, okay, of the comparing between the accuracies. So when we generate different model, we have the different result, right? And we want to ensure that which one will be better. For example, if in the regression model you have the R-squared, adjusted R-squared, right? Which one have the higher adjusted R-squared? That means that's better. But the same thing apply for the forecasting error like this. But the smaller it is, the better the model would be. Ok, thì đến lúc này mình sẽ so sánh các model với nhau. Nếu mình muốn biết là các model, hồi nãy mình vẽ mấy cái đôi model rồi mình nhìn thấy nó ở trên mình nhìn thấy nó ở trên mấy cái để thầy lui lại cái này. Mình nhìn thấy mấy cái model này đúng không? Mình vẽ model rồi tùm lum hết rồi. Mình thấy model đây, nhìn thấy đây. Nhưng thầy cũng nhìn con mắt thôi, thì không biết được là drip method thì thầy đoán là nó được. Rồi thằng seasonal name này nó được. Nhưng mà that's just all the visualization, that's all the graphical effect. Okay, they don't have kind of like numerical measurement, and this is how the people measure cho. Okay, những giá trị này càng nhỏ thì cái model càng tốt, vậy thôi. Mọi người chỉ cần nhớ những vấn đề này. Nội dung thứ hai là công thức nó tính, thì thật sự thầy cũng có bắt buộc các bạn phải thuộc được các công thức gì, nhưng mà nó cũng không khó đâu. Nó có nhiều cách. Cách thứ nhất là mean difference. Đây ví dụ như đây này, self dependent errors này, the mean. Ok, thì ví dụ thầy demonstrate nó ngay trên Excel cho mọi người hình dung cũng được, chẳng có gì. Thì ví dụ như đầu tiên là bạn muốn tìm được mean MAE đúng không? MAE thì quay lại câu chuyện của đây. Rồi, thì MAE. Ok, residual. Rồi, thầy phải bỏ cái này kiểu này nha. Thầy sẽ tính nó theo kiểu là đây theo đúng kiểu là giá trị ngày sau, thầy sẽ fit nó bằng giá trị ngày trước. Đó, đây sẽ là cái fitted value. Ok, cái bọn này mình bỏ đi, những cái thằng này thì mình bôi tiếp. Okay. Let's go and do it. Okay, now remember about this one, and maybe I have the difference between like this one could be 100, right? 101, right? And I'm gonna check it, what the difference between the two. Okay, so standard this will be what I say about the difference between, I make it smaller, okay. Okay, so first of all, I talk about the difference, that will be called the MAE, okay. The mean of absolute errors, okay. So first of all, if I want to do it, I have to measure for the difference between the real values and this one, right? The forecasting values. Oh no, đâu phải cái này. Oh right, for this, okay, the difference. Okay, so I will have to measure for the difference between the real values and the forecasted value. Okay, this is the difference, but maybe there some of them will be some of them may be like larger, there's some of them may be smaller. For example, I do 90. This one will be just 90 something. So some of them is large, some of them will be small, right? Yeah, negative or positive. If I say just average like that, that's very stupid. Because they will just add up and divide the other. Okay, they will just add up and then they just like eliminate each other. So that's the reason why over here, instead of that, I will say the absolute function. So if I apply for that one, now it's different a little bit. Okay, that's what they say, the mean absolute errors. So the root is mean absolute error. How we gotta do it? So if you have already the RMSE, okay, the RMSE will equal to the same. So the first of all, you have to use the difference between they two, right? Right, and then they squared R. Okay, value may be a little bit. No, not that bit. Okay, and I do it the same, and then later I take the root square errors. Okay, root means square error. So then I take the mean of them. I take the average. This is the average of all the squares of all the mean, all the residual. And then one more time, I use the square root to put it back. Okay, a little bit different to the absolute, but they close. Okay, percentage errors. Những cái này thôi mấy đứa tự coi lại. So the percentage will be the difference between the standard errors. Like this one, the standard errors, the difference between them all, right? The real residual, the real values, and the fictitious values. Okay, then divide for the real values. It's the percentage difference. Okay, if you change it and put it into percentage, they will be the difference. And then now you just have to remember, put them into the MAP. That's mean absolute percentage errors. So that's mean overall you have to do it absolute with all the data, and you apply them for all of them, and you use the average. Okay. Right, the same thing. Right, the same thing you can apply for the other kinds of the thing. Okay, you do it by yourself. I don't have the time to just demonstrate everything on Excel for you to do it. But however, I demonstrate the thing on like on our studio, and you can understand about how we can conduct them all on the R studio. But basically, with the kinds of very easy function, you do it with the data analysis. You do it with the forecasting function. You do it with the kind of like exponential smoothing. You see this all. They can do it like average Moran. They can do it all forecasting based on this one. Nếu mà mọi đứa dùng trên Excel vẫn làm được, nhưng mà nó yếu ấy. Đây, bình thường thôi. Bây giờ cái gì mình làm được mà dễ thì mình cứ xài, chứ mình đừng có nhất thiết là mình làm cho khó bản thân mình như vậy đó. Okay, forecasting. Now let's do it, and let's check it with the chapters. Lab practice 3.44. Okay. No. 3.4 about the forecasting. Racy. Measure. Okay. Now how we gonna do it? Okay, so first of all, one more time I use the Australia beer dog. Okay. But however, I'm just going to just use for ours as like for the US beer. I want to just do it with the window. I want to separate them into the two different windows. So first of all, I use a function. I want to create the training data and the testing data. Only that way I can create for the accuracies function to just compare between the performance of the different method. Okay, so window maybe according to the book, I would just use for like start from 1995. Quarter one of the 1995 until the last quarter of the 1992. Okay, so this is the basically the data, but I don't want to use it. I want to start like no maybe in 1992. Okay, I want to start from the fourth quarter of 1992, and what else? Like I want to end it in the first quarter of 2007. Okay. Right, this is the data. This is all the data from 1992 into 2007. And I want to put them into the train data sets. What I say. So for the rest of the data, right, from the 2008 until 2010, the last 10 observation, I will use them for the testing data. So the same thing, and I use the same function I created, but I gotta use it from start from. I don't have to clarify about the end. Okay, I just want to start from 2008, right? The first quarter. Okay, I have the trend data and the test data already. Now let's just do it with the comparison between them two. So I first of all created based on the trend data. Okay, I applied for the mean forecasting. Okay, with equal to x equal to 10. Of course, because I'm going to check it with the test data, right? The test data had the 10 day. So with the trend data, I generate for the next 10 day to compare with the test data. This is the forecasting of the test data. And I'm going to just check it like I can compare them, right? Then later I can compare them. I can compare the performance by the graph. Okay, so if I want to do it, I can compare them by I just use the IUS. Okay, so I would just use this like IUS beer. Okay, with the original data I will find. I put them into the original data. So beer, and I want to use a window, but now I want to cover all the periods. So window, and I start from C 1992 first quarter. I want to get it all the data, original data, including not only just the trend data, but also for the testing data. So apply them for the auto plot, right? No data. Then I'm going to add in for another layer. So auto layer, remember? With this data I will call this the fit one. That's the forecast one, or I can say the fit one. That's okay. The same. Outer layer. So I could put it on like the fit one layer, and then the series name will equal to the mean method or average method. Okay, and I have to clarify about predicting interval equal to 4 for the visual effect. You see it over here, okay? That could be the fit data compared to the real data, right? Now I'm going and do it and redo it for a lot of time. I want to generate for the second model, but now that the fit 2, the train data, but now I'm used for the native function. And with the same idea philosophies, I would just apply for the outer layer, but now I'm going to generate it for the naive method, okay? And this will be fit 2, okay? Right, all the data now I have the two compare between the real data, the naive methods, and the average method. And that should be all. I would just one more time repeat it. One more time. I do it like a lot of time. I will create for 4 methods that's already learned, right? You already learned about the name. The 3 could be seasonal name. Okay. Oh my God, I've run all the data one more time. Sorry. Yep. I run this one. Okay. And one more time, I create for another. That should be not name, but random walk. Thing with the trip equal to true. And that should be my 4 different model. Okay, I have a fit 1, fit 2, fit 3, fit 4 from the mean name, seasonal name, and the drip method. And I also one more time just generate for the same graph with the different layer. Okay, this one will be that name plus my seasonal name, and this will be fit 3. Okay, and I click on like blood. One more last one. This will be not the seasonal name, but like this will be the drip method. Before all the function had been added in. Okay, you can say the time if you really want to just decorate for that, you can put in like it's lab. Okay, and like on where I do years with for the X level, Y level, I put it on like for this one the year, right? Megaliter. Okay, and of course I want a GG block, GG title. This could be the forecast for quarterly. The production. Okay, and then one more a guide, the function guide, and I want to have the series. I don't want them to be series, but I want to change for the legend name. Okay, the legend title and the guide. Okay, and the title I want to change it into the forecasting method to clarify that there we had a different forecasting method. Okay, this will be for graph. Okay, and you see like this will be comparison between the original data, the forecasting by seasonal, the real data. Black one will be the real data, the violet one will be the seasonal, and then the average, the naive, the drip methods, 4 methods are compared with each other. Okay, but however that should be the graph, remember. Now the time to compare method by the benchmark number. Okay, so in the benchmark number criteria, we can go and generate it by easily call it accuracies. The accuracy function, and we want to put them into fig 1 because that result between the fig 1 and the test data. Okay, remember about we had the test data and the fit data. Fig 1 will be the all the data. Remember, this will be fig 1. Okay, all the data from forecasting, and this will be the test. All the data from like Q1, real data from Q1 of 2008 to like the real data of the 2010, right? We compare between these ones, and the real data. Okay, so that's the point. So this is the accuracies. Remember about them. ME, don't care about them. RMSE important. MAE important. MPE important. MAPE important. MASE important. That should be it. So 5 of this one you can check like that. So we just mostly want to care about the test set, right? 38 something, 34 minus 30 something, whatever. Okay, let's go and check it with the another one. Like this will be first of all, right? This is the accuracies, the accuracy of the average method. Now let's see it, like what could be them compared to the accuracies, but now I want to fit to that's the naive method, right? Average, but this not, but like the performance of the naive methods. And you see over here, if you compare between the two models, the testing RMSE of the first model compared to the second one had larger, and the same thing with the MAEs. This one larger, this one larger in the absolute value, larger. So nah, the second model, the naive methods, is not so good. Okay, the same thing apply for the third model, for seasonal model, and this is seasonal naive. And it looked like we had the great improvement. Okay, the seasonal naive, they better than the first model and the second model if you compare with the RMSE, right? The MAEs and also the MAPs and MASE, they are smaller than the previous one. So up until now, the third model is the best. And compare now with the fourth model. This will be for the trip method. This one, not so good. The MRSE is too big. Okay, they're even bigger than the naive methods. The MA is too big too, and the MASE, they are too big. So with me, this model with very small forecasting errors, that should be the best model, as I'm gonna say. So I can say like the best, the fit 3 here would be like seasonal method, right? Seasonal naive method is the most accurate one. You got it? And you can compare between them all the kind of model based on the accuracy function like this, or you can compare them based on the graphic like this. So the same thing I will require you guys to do it on the final in the assignment number 2. Okay, the assignment number 2. Assignment number 1, homework number 1. You will have to do it all the thing. The later, remember about the chapters, we still have the kind of like prediction interval. There's some kinds of codes that's along with them, and you have to take a look into my video about the instruction I already posted on. Okay, you can take a look onto the instruction of the toolbox and how you generate this. I saw you already on the video, so I don't have enough time to just demonstrate everything on Studio for you in just 3 hours. But that's going to be all the thing of the today's session. If you're done with that, you will be ready for the homework number 1. Remember, also have the R code with 4 to submit on. Okay, you got it for this one. Up until now, any kind of problem, you don't understand anything or thing like that, guy? Any problem? If that's